Consider a rigid body rotating about an axis with an angular velocity omega. Let the axis be y. Let's call that axis be y dash. Suppose this rigid body be made of masses like masses m1, m2, m3, etc. up to mn, such that sum of the masses m1, m2, m3 and mn gives the total mass of the rigid body. Let the distance of the mass m1 from the axis of rotation be r1, that is, this one is perpendicular distance. Similarly, the distance of m2 be r2 again. Every distances are the shortest distance from the mass to the axis or the perpendicular distance. Similarly, that of m3 is r3 and that of mn is rn. We need to find the kinetic energy of the rotating body about the axis, or rotational kinetic energy of the rigid mass. So that for that we have the kinetic energy of the mass m1 is equal to half m1 v1 square, where v1 is the linear velocity of the mass m1, plus the kinetic energy of the second mass will be half m2 v2 square. We are going to find the total kinetic energy, find the kinetic energy of the rigid mass. So we have to add all the kinetic energy of these masses. Similarly, for the third mass, it is half m3 v3 square plus etc. This goes on, and for the last mass, the kinetic energy is equal to half m1 mn vn square. But you know, the velocity of any body, linear velocity, will be the distance of the axis, the distance of the mass from the axis times the angular velocity, or radius into angular velocity. This is the expression for linear velocity. Applying this in here, that is, kinetic energy is equal to half m1. Instead of v1, you can write r1 omega 1 square plus half m2. v2 will be, v1 will be r1 omega 1 and v2 will be r2 omega 2 whole square plus 1 by 2 m3 r3 omega 3 whole square plus etc. up to half mn times rn omega n whole square. Also, if you look at the rigid body, every mass is on the rigid body. So, which means every masses have the same angular velocity. That is, but omega 1 equal to omega 2 equal to omega 3, etc. Omega n we have, that is equal to omega, the angular velocity of the rigid body. So kinetic energy Ke is equal to half m1 r1 square. Instead of omega 1, you can write omega square plus half m2 r2 square omega square plus half m3 r3 square omega square plus etc. to half mn rn square omega square. Clear? Since the angular velocity is constant and it is common for every term, you can take that outside. So the relation will be kinetic energy is equal to half times half omega is half omega square. You can take that outside since it is common for all the terms. The rest of the terms will be m1 r1 square plus m2 r2 square plus m3 r3 square plus etc. up to mn rn square. But you know, mass times radius is the mass times the square of the radius is the moment of inertia. So the moment of inertia of all the masses gives the moment of inertia of the rigid body. So this is equal to half omega square I, where I is the moment of inertia of the rigid body. Since we have I is equal to m1 r1 square plus m2 r2 square plus etc. up to mn rn square. This gives the moment of inertia. So kinetic energy of a rigid body rotating with an angular velocity omega is equal to half I omega square. Clear?